Kaspa's Toccata hard fork is scheduled to hit the mainnet in 23 days, June 30th, 2026. If you've ever tried to mint something on Ethereum during peak demand, you already know what a blockchain auction feels like. Okay, maybe you haven't experienced that directly, but you have felt it somewhere else. Uber surge pricing, concert tickets selling out in seconds. You're not just paying a fee, you're competing in real time against everyone else trying to get in. And the price keeps changing while you're still trying to click confirm. That's the moment Kaspa is trying to rethink. Last video we talked about Silverscript and how Kaspa is taking a different path than most smart contract platforms. Instead of one shared system where every application completes for execution, Kaspa is building around local state. Not one global computer, but millions of independent units carrying their own logic, processing in parallel instead of one by one. You can think of it like multiple entrances instead of a single gate. Silverscript gives developers the ability to program that system. Toccata is what prepares that system for real demand. Because the real problem Kaspa is solving isn't how do we add more features. It's this: what happens when demand spikes? On most blockchains, that single gate moment turns into a bidding war. Whoever pays more gets in, everyone else gets priced out or delayed. And this is where KIP 21 comes in. App A pays for App A, App B pays for App B. But here's the important idea. If one application suddenly gets overloaded, it doesn't automatically push the entire network into higher fees. Because on most blockchains, one spike in demand creates a chain reaction where everything becomes more expensive for everyone. Kaspa is trying to reduce that effect, not just by splitting load, but by increasing how much demand the system can absorb before that bidding pressure appears. This is one of the key pieces required for scalable zero-knowledge applications. Toccata introduces ZK verification opcodes and infrastructure for based ZK systems. Instead of every application doing all computation directly on-chain, apps can prove they executed correctly and submit proofs instead, even during high demand. The network avoids the same execution bottlenecks seen in traditional systems. And this is pointing to something bigger: verifiable programs, or VPROGs, applications that scale independently while still composing together across Kaspa's block DAG. Silverscript showed how Kaspa programs the local state. Toccata shows what that becomes under real demand. And instead of discovering scalability limits after millions of users arrive, Kaspa is trying to understand them before they do.